Hi, my name is Steve Faulkner and I'm with the SolidWorks Education team. Welcome to another video in the SolidWorks BAJA SAE video tutorial series. In this video, I'll be covering some tips and tricks for dealing with large assemblies. When talking with students or responding to your questions, this is one of the most frequent topics that I get asked about. How do I stop my computer from crashing when I'm working in large assemblies? I hope to answer that question today with some tips and tricks in this video. I won't follow the same format that I have been with the other videos where I walk you through a model. Instead, we'll be looking at a few student-submitted models and seeing the good things and the things they could improve on with their modeling skills and how they relate to large assemblies. The best way to immediately impact large assembly performance is to set up the software correctly. Many of you might already realize this, but under the Tools command, scrolling down to Options, we'll bring up a display of all the things we can configure in SolidWorks. Under the Performance menu, there are several options to improve performance for less powerful hardware, such as turning off high-quality transparency or changing the level of detail on curvature. You'll have to play around a little bit to find the optimal settings for your system. Under the Assemblies tab, you'll find the area where we can configure large assemblies. The most important part here is selecting how many components are required before SolidWorks goes into large assembly mode. By default, this is 500. If your full car model doesn't have this many parts, or you're on older hardware, you might want to bring this down to a lower number. Now that our software is configured properly for our system, let's take a look at some actual modeling techniques that can improve large assembly performance. Now this may seem strange, but the best piece of advice I can give is to avoid large assemblies. And what I mean by that is to avoid putting a lot of parts and assemblies into one single assembly. Make sure you take advantage of sub-assemblies and sub-sub-sub-assemblies. In this partial full car model that was sent to us, you'll see that many of the engine and transmission components have just been dropped into the full model assembly. For best performance, you should assemble an entire system at once and then insert systems separately. A good example of how to do this can be seen in this model, where the entire front suspension is one assembly and then is inserted into the full car model. This is just one example, and I won't go into too much more detail, because I really believe that how you set up your assembly hierarchy will largely depend on your design intent and goals. The third tip is to take maximum advantage of configurations. When working with models that can be complex or represented as simple parts, remember you could just make a configuration for each. For a good example of this, let's take a look at the wheel. In this model of the wheel, there are two different components, and each is fairly complicated with many complex surfaces. This is another model of the same wheel, but modeled to the absolute minimum as a single part with only a few features. If you have the time, my best advice is to try to do both, and have a configuration for each, so that if you're working with the full car model, you can use a simple model that is less taxing on your computer and the SolidWorks software. But if you're taking screenshots or doing renderings, you can always change the configuration to a model like this that will give you the level of detail you need. The fourth tip is to confine and constrain every single thing in the model. I found that frequently students will leave several things unconstrained because it looks cool and they can drag it around. An example is this part right here with the wheel rotating around the upright. While this may be great for showing the model off to other people, it actually is very taxing on the software when you're trying to work in the model, because every time you move or reopen something, it's going to want to rebuild and recalculate the position of that component. One place that people frequently forget to constrain components is on bolts, nuts, and washers. One way to avoid this is setting up configurations for your car that do not include bolts, nuts, and washers at all. If this is important to your design process, you may or may not want to do this, it's up to you. But if you are including bolts, nuts, and washers, make sure to fully constrain them. Often people will constrain them into the hole and against the surface like this, but the bolt is still able to rotate axially. This is just another unknown variable every time SolidWorks has to rebuild or reopen the assembly. That concludes the large assembly tips and tricks video. I'd like to specifically thank Waylon Walker from the Iowa State BAJA team for suggesting this topic. And as always, if you have any comments, questions, or suggestions, don't be afraid to email me at sfaulkner@solidworks.com.